Okay, so for today we're going to talk about circuit capacity. And what that requires is a knowledge of some terminology and a knowledge of some calculations. So we're going to go through that right now and exactly what this means. So when we're talking about circuit capacity, we start with a general lighting load, and that is a calculation that's performed by a contractor when doing the load calculations for a service. It's based on the square footage of the occupancy, excluding any unfinished cellar, attic, and open porches. And a good example is found in Annex D1A. And this is Annex D1A where this is the calculation that the contractor would perform for the service. But here is what we're going to be talking about, this general lighting load. And that's based on the square footage of the occupancy. In this case, it's based on the square footage of a dwelling that's 1,500 square feet. And what is done is the general lighting load is based on a unit load that is in units of VA or volt amps, and it's dependent on the amount of that is dependent on the occupancy. And we find those measurements at table 22012 under general lighting load by occupancy. So this is an example using a dwelling which is assigned 3 VA per square foot, and I'll show you that in a minute in the next slide. So it's simply we take 3 VA per square foot and we multiply that by the existing square footage of the dwelling or occupancy. And in this case we get 6,000 VA or watts required for the lighting load. Now that table is here, 220.12, and it shows the amount of watts for each of these occupancies. So the contractor has to know whether they're dealing with a hospital or a dwelling or a barber shop or a bank or a restaurant or a school. They all have different wattages or VA per square footage, and you take that and you multiply it by the square foot of the occupancy, and you get your general lighting load. It's a pretty simple calculation. All you have to remember is what this table gives you and where it's at. Table 220.12, general lighting loads by occupancy. So to determine circuit capacity, you have it's defined as the total power or wattage allowed in a given circuit size. So as an example, you have a 15 amp circuit in a 120 volt service. We simply multiply that 15 amps times 120 and we get 1,800 watts or VA. So 1,800 watts of capacity is found in a 15 amp circuit that's in a 120 volt service. And the same thing can be done here with a 20 amp circuit. So a 20 amp circuit and a 120 volt service will accommodate 2,400 watts or VA of power. So it's a very simple calculation again to determine the circuit capacity. Now one has to know whether you're dealing with a continuous load or a non-continuous load. Let's define continuous load here, and that is a load where the maximum current is expected to continue for more than 3 hours. Some places include a store, an industrial plant, common property in an apartment or condominium complex. And the code requirement at 210.20A says that the breaker should not be less than 125% of a continuous load, or the OCPD, which is the overcurrent protection device or the breaker, shall not be less than 125% of the continuous load. In other words, the load can't be more than 80% of the breaker size. So in this case, 16 amps is all that's allowed on a 20 amp breaker in a continuous load, excuse me. So for a continuous load, we take 15 amp circuit in a 120 volt electrical service. If it was a continuous load, we would take 80% of that. So 15 times 120 times 80 is 440, or I'm sorry, 1,440 watts of, that's your circuit capacity in this case. If we're dealing with a 20 amp circuit, then you take 20 amps times 120 times 80%, and you get 1,920 watts, which is your circuit capacity. So now we've determined our general lighting load, and now we have our circuit capacity, and we just divide one into another, as I'll show you in the next slide here. But first, let's talk about a non-continuous load, and that is where the load is not expected to continue for more than 3 hours. And these are places like homes or motel rooms. So the circuit capacity in a non-continuous load would be 15 amps times 120 volts. And you could do the calculation here. 1,800 watts is your circuit capacity for a non-continuous load. So let's do an example here. First, the formula that we're working with is called the circuit capacity formula, and that is your lighting load by occupancy, and we divide the circuit capacity into the lighting load, and you get the number of circuits for that particular lighting load. So let's do an example here. For a non-continuous load, 1,600 square foot dwelling would require how many 15 amp lighting circuits? So we go to table 220.12. We notice that there are 3 watts in a dwelling, 3 watts per square foot for a dwelling, and we have 1,600 square feet. We multiply the two, and we get 4,800 watts. Now we want to determine how many circuits, so our circuit capacity in a non-continuous load, we take 15 amps, multiply it by 120, and we get 1,800 watts. And we just divide the lighting load by our circuit capacity. We get 2.67. Of course, you can't have a fraction of a load. You have to do something with these extra watts, and you just round up to 3 circuits. So you'd have 3 15 amp circuits for a dwelling of this size using 15 amp circuits. Here's another quick example. An 8,000 square foot restaurant would require how many 20 amp lighting circuits? Again, we go to table 220.12. We see that 2 VA is assigned for a restaurant. We multiply that by 6,000 square feet. We get 12,000 square feet, or 12,000 watts, excuse me. And for a continuous load, which will be on a 20 amp circuit at 120 volt service, we take 80% of that, and we get 1,920 watts for a continuous load. We divide that into how much we have, how much our load is, how much our lighting load is, and we get 6.25. You have to round up to accommodate for these extra watts, and you get 7 15 amp circuits. So that's our circuit capacity, and I hope you enjoyed it.